Right, one of the most important things you'll have to do in the biology is exponential growth. Okay, so this is like bacteria. Think about cells splitting. One cell becomes two cells become four cells split into 8 cells, 8 cells split into 16. So things are doubling, okay? You're doubling the amount. Now, this can get very, very big numbers pretty quickly, even though you don't realize it, okay? Think about it, okay? You've got one thing. It will double to 2. That will double to 4. That will double to 8. That will double to 16. That will double to 32. That will double to 64, okay? And so on. So, imagine if this is things that are doubling every hour, okay? So after another hour, 2 things, another hour, 4 things, another hour you've got 8, another hour you've got 16. So, it's soon pretty much in one day you can have a lot of bacteria or cells splitting after 24 hours. Things doubling, okay? So this is exponential growth, okay, such as bacteria. Okay, bacteria increasing, doubling, okay, every 10 minutes or every half hour, whatever it is. Now what I've got here is actually the exponential equation for things doubling, all right? Now notice it is not x squared as we've done before. X squared graphs, remember, look like this, okay? Every time you square something, you're always going to get a positive answer, okay? So you're always going to get positive answers every time you square something. Now, this is not an x squared graph, okay? This is a 2 to the x graph. So I'm going to put the x's in the exponent. I'm not going to put the x's in the base, all right? Now, some of it will look very similar, and you'll see when we actually graph this. But whereas an x squared graph is this U shape, an exponential 2 to the x is actually going to be slightly different, and we'll see why, okay? So, remember, I'm now going to graph 2 to the x, not x squared. So, here we go. Again, just plotting points. Right, when x is 0. Okay, so here we go. On the right-hand side of the screen, what's anything to the power 0 again? Okay, remember, this is the x. This is where I'm putting the x's. Anything to the power 0, way down here, 1. Okay, see that? I put it there. Okay? So, when x is 0, y is 1. There, that's my first point. Okay, so how about when x is 1? What's 2 to the power 1? Anything to the power 1 is just itself. 2 to the power 1 is just 2. So when x is 1, again I'll come down here, when x is 1, y is 2. Okay? Hopefully I do this quite accurately. When x is 1, y is 2. When x, when x is 2, okay? What's 2 squared? 2 squared is 4. So when x is 2, down here, okay? So you see, okay, things are starting to, increase a little bit, speed up. How about when x is 3? Sorry, I should put that there. Sorry, I put my numbers over here. 2, 4. Okay, when x is 3, what's 2 cubed? That's 8, okay? So we've got 8 here. Right, here's the 3 down here. So when x is 3, y is 8, about there, okay? Right, here we go. Keep on going. When x is 4, right, 2 to the power 4, 2 times 2 times 2 times 2 is 16, right? So when x is 4, down here, we're about here, y is 16. Right, now we're starting to shoot up, aren't we? Okay, can you see that? Right, so when x is 5, okay? Right, again down here. 2 times 2 times 2 times 2 times 2 is 32. Okay, now we're really starting to shoot up. I've jumped right over this equation here, all the way up to here. Okay? Right, so let's erase this. Because that's all I can go, because also I'm going to go way off the scale here. I can't do any more than that. In fact, that's why I deliberately put 32 there. Okay? So, I am smart. Right, so this is what the graph looks like so far, if I can join these together. Please help me. Not too bad, I could have missed it up here. Okay, right, that looks like so far. Now, can you remember what the x squared graph looked like? The x squared graph looked like this. But then it came back up again, remember? Came back up again. The U shape. So far, this looks like an x squared graph, at least on the right-hand side of the y-axis. But, right, so remember, look at this now, okay? That's the right-hand side of the y-axis. I forgot to fill in these. Okay, what's going to happen when x's are negative? So remember, when we had the x squared graph, when we squared negatives, we always ended up with positive answers. That's why, when we got to the negative numbers on the y-axis, we came back up again, all right? Because we always have positive answers when we square something. Right, now can you remember what we have when we have negative exponents? Remember, we end up with fractions. Now watch this. So I'm going to jump over to slide 2. Okay, I'm just going to go over to slide 2. Right, here we go. Okay, so remember, this is what I've got so far on the other side. I've really expanded the scale here so you can get close in, a bit more detail. So remember, that's going way up to 32 from the previous graph. Okay, let's have a look at this. When x is negative 1, okay, so what is 2 to the negative 1, okay? Remember, it's not negative 1 squared, it's 2 to the negative 1. Remember this? 1 over 2 to the positive 1. So that's 1/2, right? So when x is negative 1, y, and I've got to be careful here, is, so it's about there, okay, about half, between 0 and 1, okay? Right. When x is negative 2, okay? Remember, 2 to the negative 2 is 1 over 2 to the positive 2. That is 1 over, that's 1/4. So again, when I come to here, okay, got to go even. Oof, this is not going to be very accurate. Okay, so about 1/4. All right, let's try to do that a little bit. Well, that's not quite 1/4, a bit higher there maybe. Okay, maybe 1/4, okay? Right, here we go again. What is it when we have a negative 3 there? What's 2 to the negative 3? Okay, so remember, this was 1/2, that was 1/4. Recognise the pattern? It's going to be 1 over 2 to the positive 3, which is 1/8. Now, this is going to get very hard to sketch soon, okay? Let's just erase that. That's 1/8. Okay, let's try this. Ugh. If you realise what's going to happen, this is going to be 1/16. Again, 2 when it's negative 4. I get 1 over 2 to the positive 4, which is the 1/16 I just said. Oh, I don't know. Now, okay, so look at this. Right, if I go back to the previous slide, if I can somehow put this on, it's not going to be very hard to do, is this? Okay, because I have the detail. Now, can you see that? It is not going back up again. It is going, okay. What happens is it gets closer and closer. Now think about this. I know that eventually you think it might touch that x-axis, but think about what all these coordinates are going to be. Let's go back to the slide. 1/16, okay? Next one will be 1 over 32. Next one will be 1 over 64, okay? I will never reach the x-axis. I'll just get closer and closer to it. It's like I always say, I get closer and closer but never touch, a bit like one of my ex-girlfriends. But anyway, enough of that. So what I'm trying to get at this is, let's go back to this here. This is what the exponential graph looks like. Now really, in real life, you don't have to worry about this side, all right? Because in real life, we don't have negative numbers as in time. Okay, so in other words, if I start here, okay, if I start here, at the start, when time is 0, when the x is 0, okay, then I keep on going, maybe after 1 hour, after 2 hours, after 3 hours, after 4 hours, after 5 hours, what's happening to the bacteria? Can you see? It's really, really increasing, okay? It's doubling each time. So this is you doing an exponential graph, okay? So if we don't take into consideration the negative x's, okay, this is what I want you to consider, okay? It's no different than plotting anything else. It's just you're putting the numbers in the exponent instead of the base that we did for the x squared. Okay, so this is exponential growth.